In today's Daily Dose of Math, we're going to look at pairs of straight lines, the relationship between two lines. We have four possibilities. A pair of straight lines can be parallel and distinct, or they can be parallel and coinciding. They can be intersecting perpendicular, or they can be intersecting non-perpendicular. Now, one of the problems with this topic is that these words are too long, which makes it hard for me to fit all of these words on my page when I'm trying to explain it. And it's also a bit of a turnoff for the student who might think, okay, this word is too long and has too many syllables. I think I would just like to leave this question blank. Well, that's a bad idea. But I'm dealing with this by using half of my chalkboard just to write the four different relationships that can exist between a pair of lines. And what I've done here is I've made 5 lines called line 1, line 2, line 3, line 4, line 5. And I'm asking 4 questions. Because you don't ask this question about a single line. You always have to have 2 lines when you're talking about it. So line 1 and line 2, what is the relationship between those two? Which of these relationships do they have? And how do I show that that's the relationship? And then line 2, line 3, line 3, line 4, line 4, and line 5. So here with this little brace, I'm going to show my answer to the relationship between lines 1 and line 2. This brace is where I'll put the relationship between lines 2 and 3. Here I'll put the relationship between lines 3 and 4, but I'm going to give myself a bit more room by writing that answer a little lower down. And finally, the last question, lines 4 and line 5, I'm pointing down here. I'll put my answer down here. Let's get into it. Line 1 and line 2. Which of these relationships applies? Well, the first step is always make sure all of the lines that you're using are in y equals ax plus b form. Very useful form for answering questions like this. And in fact, I've made this whole example quite easy by putting most of the lines in that form already. But line 2 is not. Line 2 has, the y has a numerical coefficient of 2. I need to simplify this. I'm going to divide everything in this equation by 2 so that I can cancel here, isolate my y, and I have the equation y equals 2x plus 3. So what I'm revealing now is the fact that this equation for line 2 is actually exactly the same as the equation for line 1. They're both y equals 2x plus 3. They're both really the same line. And that means that these two lines have to be parallel and coinciding. So I'll write that, even though it's using up most of the space I have available. And I have to write really small, which means it's hard for you to read. But I also want to justify that. And I'm going to say A1 equals A2 and B1 equals B2. Here again, we have the usefulness of expressing the lines in y equals ax plus b form. A is the slope. Both of them have a slope of 2. The slopes are equal. That means they're parallel. But both of them also have a b of 3. The y-intercepts are the same. That means they're not only parallel, they're parallel and coinciding. So in order to answer the question, when you have parallel lines, there are 2 steps. You look at the slopes to answer the parallel part, but then you also look at the y-intercepts to see whether they're coinciding or not. Let's move on to the second question, which is lines 2 and 3. We already have line 2 simplified. It's y equals 2x plus 3, and line 3 has y equals 2x minus 4. A2 equals A3. The slopes are the same. So I know they're parallel. I'll start writing my answer. Parallel. I'll try to spell it right. But this time the y-intercepts are different. The b's are different, so they are not parallel and coinciding. They are parallel and distinct. And why? Because A2 equals A3, but B2 does not equal B3. I have enough information to not only prove they are parallel, but also distinct. I have answered the second question. Now we move down to lines 3 and 4, and we look at that question. I can see right away that the slopes are not the same here. These lines are not parallel. The slope of line 3 is 2. The slope of line 4 is -0.5. So I know they're not parallel. They have to be intersecting. I'm going to start writing the answer. They are intersecting, but are they intersecting perpendicularly or non-perpendicularly? The answer is perpendicular. How do I know? Well, at a glance, I know that 2 is the negative reciprocal of -0.5. That's one way of expressing it. But I also can see, first of all, I'm going to prove they are intersecting by saying A3, the slope of line 3, is not equal to A4, the slope of line 4. 2 is not equal to -0.5. But I also can show that A3 times A4 equals -1. When you have two numbers that are negative reciprocal of each other and you multiply them by each other, you always will get -1 as an answer. So -1/2 times 2 equals -1. I can see proof that these two lines are intersecting and they are perpendicular. So I have my answer now for the third question. Finally, we are at the fourth question, lines 4 and line 5. Again, I can see they don't have the same slope, so they are going to be intersecting. But -1/2 times 1/3 is not, well, it is equal to -1/6. It is not equal to -1. So I can also write -1/2 times 1/3 is not equal to -1. And I have a lot of the math part of my answer. They are intersecting, I'll move this arrow a bit, non-perpendicular, as long as it takes to write, it's worth it. And as messy as it is to write when you're down near the bottom of the whiteboard, these two lines are intersecting non-perpendicular because A4 is not equal to A5, so they are not parallel. And A4 times A5 is not equal to -1, so they are not perpendicular. Notice how in the last two questions, I never mentioned the B. I never mentioned the y-intercept. Because once you have shown that two lines are not parallel, you don't need the y-intercept to answer the rest of the question. The y-intercept comes into play once you have shown they are parallel and you're trying to figure out if they're parallel and distinct or parallel and coinciding. So these four examples cover all of the different things that can happen when you're asked this type of question. And notice how I didn't show you a graph. Because although a graph can make it really easy to see if lines are parallel or not, or perpendicular or not, so long as the graph is drawn well enough, it's true that the graph is unnecessary. If we have our equations in y = ax + b form, we don't need a graph at all to answer this question thoroughly and completely. That is today's Daily Dose of Math. Please like, subscribe, and share.